talking about the future, but keep in mind that the future is a part of what we are living right now, and this is what we have to understand. We already have some signals to looking for the future. I like to have this talk focusing on to what we had, what was the past, because for us it's the past. Cloud computing is the past, because for example in Messina we started the experience on cloud 2007 with the first European project that moved from the grid to the cloud. It was named the Reservoir. It was a successful project. I remember very well when the project officer, Maretzkari, a Greek guy, she said, oh, I feel that Amazon is trying to copy this kind of a project because we started soon, have a great idea. And then...
No, you're self-conscious. We just realized that you're self-conscious is excellent.
So, and then we are moving in fog. We are moving in fog computing, in edge, all the stuff. But what is happening there, behind the corner, is a massive elements coming in. In the idea of Osmotic, we're trying to bring all together, also having in mind big data. And then we go in looking for what's happening in terms of abstraction of stuff. You know very well what are microservices, and the idea is to leverage them in some way to this kind of smooth application, essentially that allow to be applicable easily and in a dynamic way. This is what we are looking for. With, of course, we're talking about many times APIs, talking about RESTful, co-op, so on and so forth. Why APIs? Because this system needs to interact with each other in a massive way, not in a secure way. Come on, I don't want to make any issue. I apologize for that.
Social media.
Yes, because you know the summer school right now is on Twitter. You know, it's a social. It's how it works. Good or not, no sharam bad. It's how it works. Okay. As I said, the part two. As I said, the part two is in terms of gathering all the stuff, brainstorming, and going towards osmotic computing. Okay? This is a sensitive idea. I like to start with the Gartner hypercycle because it's as human behave. We have some expectation. We strongly believe what we are looking for is great. It's the peak of expectation. When something happens, I don't like it, go down. But you have to be careful. We have to see there consolidation. This is what I totally feel to be on the cloud. It was on top 2009, long time ago. Is why I totally believe that the cloud is consolidated right now. Okay, and cloud right now is in this domain. Everybody is talking about cloud, and everybody knows what is cloud. Which is funny. I'm interacting with a lot of companies in Italy. They need cloud. After years and years, they realize it's essential to have cloud for them. We know everybody what is cloud. Why I'm putting the picture of cloud? Because cloud has changed in our mindset. Cloud was really destructive. We changed how to do stuff. For what reason? Because it was like a tsunami also towards Europe. Even Europe tried to make clearness on the cloud because it's scared by less GAFAs. Google, Amazon, Facebook, Apple, that push away the cloud. But it's not possible, we know it. Okay? And we have a different paradigm of cloud. We have a private cloud as an example, public cloud, hybrid. It's a really, repeat, it's well-known stuff. But what was new? New was pay as you go. You click the button, you did this service, you finish, you close your agreement with the company. This is a really destructive. This has changed everything in our system. Okay? You need it, you use it, that's it. This is the new paradigm of cloud. And we have to look, even for the future, to continue in this direction. Look into IoTs, look into the services, look into everything in this way, because people can understand. When I met last month Sharam in San Francisco, it was funny to use Uber, no Sharam? Click the button, need to go from here to there, take the money from credit card, who cares? Nothing else. It was an example, like I have many more examples like Airbnb, all the stuff. Let's go look in this direction. This is where people want to go. If people want to go in this direction, let's go in this direction, because we are the master. We are the computer scientists. Smart things, humans, digital technology. This is what is happening. In any domain, we can apply it, okay? As I said, we have Facebook, I just send a Twitter image, Airbnb, doing what? Click and go. So the cloud started this idea, and others understood the powerful of the system, and they are working on that. And now we are looking to the connectivity. Last month, I went to the telco operator in Italy, asked the Telecom Italia to have the fiber at home. I'm spending 30 euros to have 200 megabit. For 30 euros, it's nothing. I have a fiber at home, it's not really fiber, it's on the cabinet. But you cannot imagine, I connect all my smart TVs, all this kind of stuff. My daughter is not complaining anymore. Now she's happy because I felt really frustrating because, oh, daughter, you have light, you have electricity, you have no. Oh, dad, I have no internet. It's commodity for her. Internet is like electricity for us. This is what I understood. Okay? This is not working. It's internet connectivity. We need it. Okay? And we are moving on the fog. By the experience of cloud, we are moving on the fog because everybody is connected. And moving on the fog means just to have some kind of abstraction where all the operators can make some business. Was me said that the business for telco operator. This is the answer to the cloud for telco operator to have their own control. Was Cisco starting with the idea of fog. They try to push this concept where, in some way, starting from the cloud, to try to distribute in very well fashion the data inside the network. Okay? This is essentially the idea of fog, and repeat, guarantee some quality of service, user experience, connecting Internet of Things. We started with the cloud, where you use smart things, are connecting each other. You see there is some conveyors, this kind of stuff. And there is a new trend. 6 months ago was announced the open fog architecture. Look, security, scalability, programmability, agility is on the network. But somebody else can say, this is the same on the cloud. What is the difference? Yes, guys, there's no any difference anymore. This is what is happening. We're going towards a dimension where everybody's asking for programmability, for abstraction, virtualization. This is a new trend. But it's not a new trend, we know it in the cloud, but it's a new trend on that. The IoT is the new trend on the networking by the fog. Okay? And edge. Look to the edge. It's the same thing. We're receiving many inputs from different domains where each of us is staying in our compartment, okay, isolated, where we believe we're providing a solution. No, guys, we are providing the same solution in different domains. If you look on the edge, you need to have some kind of a non-centralized behavior, peer-to-peer computing, similar to what the fog is trying to provide us. Okay, some kind of grid computing, clustering, but where? Close to the customer. This is the concept of edge. You can have the gateway, home gateway in the network, you can have the cabinet gateway. You are trying to use this power of computation there, okay? Guarantee good quality of service, low latency, scalability. Some words you have already seen on open fog, but it's really well known on the cloud. What is changing? Nothing, okay? The story is always the same. And now you see the big hype in the Internet of Things, where we are trying to connect all the devices. We are entering in the era of Industry 4.0, with industrial IoT, even industries is looking for this domain, okay? And of course, digital marketing. And data. Data are becoming massive. Because all these components, all this kind of stuff, I like this representation because it's amazing. Only 15 years ago, we continued to use analog storage. Remember the tape you put there is incredible. Last 20 years and everything is changing. And it's increasing the volume of data we are producing massively. Every year there's an announcement, we are producing much more data respect to the previous year. We're going not anymore from petabyte, but to zettabyte, and so on and so forth. Okay? I like it in the paper you presented, Frank. I was looking to understand it's also the trend. Next, the future. Sharon, service computing is a key paradigm that offers cross-disciplinary computation, abstraction, architecture. So you see there, we're looking for microservices, abstractions. It's great to see incorporating human concern. I fully agree. Human should be part of the loop. Remember my previous picture? I prepared the slide before, and then I was looking to the paper. We're totally aligned. We are going the same direction. Okay? One of my main concerns is confusing standard. Do you know what are confusing standards? Because each of us is talking their domain without interacting each other, but the matter is the same. Okay? And it is like this sentence. A reputable service computing is essential to play a crucial role. I fully agree. Very good. Okay? We cannot try to adjust. Okay? In our idea, reboot is Osmotic Computing. Frank. This is what we are trying to propose with Sharon, with others. I can explain you why. Okay. Essentially, the process of osmosis is something that is inside us. We live thanks to the osmosis process. Okay? Essentially, the idea to have this kind of solution that is able to move around, but it's not possible to move where you want. They need some barrier, and they need some membrane that allow you to move inside some system. At the end of the day, you don't need to have all the system with the same solution. No, you can have a part of them. What is required inside IoT, inside fog computing, inside networking, inside people, you don't need to have everything. No, you need to have a subset of things, not everything. In order to do this, you need to have some technology that allow you to have elements, IT elements, and people interacting each other in order to osmotically can exchange stuff. What we figure out in this way, okay, is this. To us, it is a mess. Usually you have cloud computing, you have a fog, you have edge, you don't know where you are. I like it what Alfred said yesterday. Services, right, Alfred? Services are provided, use cases are user needs. You're right. It's not a matter of products. But to look to user service to understand how they affect our technology. We have to satisfy them. But the reality, we don't know where we are. Are we on the cloud, big data, on remote logic, or are on IoT, on the edge, we are at home? And fog is in between. Are you sure that fog is in between, or fog is in the cloud? No, no, fog is partially in the cloud, partially in the edge. Okay? You don't know where you are. The idea, essentially, if you see here, is a mess. This is reality. This is the reality, guys. We have a mess. Okay? We have to make some clearness in the mess. Otherwise, it doesn't work. Okay? Because the reality is, you don't have one convenient technology in one domain. This is what's happening. Okay, we can fight with our colleagues from the service domain, with the networking domain. It's not on our own. It's not your own. It's not. It's both together, try to give an answer to the users. The users are a lot. Users need services. This is the idea. This is why we need to define, self-define anything. Because what is great in this domain, you can define by the software. This is really good for us. You can define any abstraction by the software. This is why we are entering the arena of software-defined anything. We can have a hybrid domain because we have already hybrid clouds. But we can have a hybrid telco. We can have a hybrid IoTs. Like federated domain. I can give you parts of my stuff, not others. What is amazing, if you move around the world, you can gain the connection by any role. Do you know what is EduRoam? It's educational roaming. It's the first example that works to allow you to get the connection all around the world only because you belong to the academia. Even the Stockholm airport is using it. Okay? It's a matter of a federation of stuff. We have to make it federated and to have a different approach for this. We can define by the software APIs, service, security, everything. Okay? And we are looking to the device, smarter, abstracted. You know what is the new trend? Putting containers inside the Raspberry. Putting containers inside the SP52 is the really small device. Abstractions. MicroPython, you can have a micro Lua, you can have a micro JavaScript. Everything is micro, but it's the same what we did in the cloud. Yes, we are looking for Raspberry device, but we are looking also this powerful small device, €2. You can buy them for €2. You can deploy what you want. There are some kind of Arduino-like architecture, and you can deploy what you want. What? Some visual abstractions. Okay, this is the concept of MPU based on Linux. Example Raspberry. Example the others, Android itself. But here you can have an example like Arduino. Okay. Also the device are ready to take this flow in this concept. Okay? To go forward. On Osmotic, you're trying to gathering all this stuff to make clearness in this domain. I know it's challenging what we're saying, but we're trying to make some clearness there. Okay? IoT, edge, fog, cloud. Why don't I find them osmotic? You need some things, I can flow to you what you need. That's it. It's a part of the game, okay? We have all the ingredients, and this is I already said. We're not talking about anymore of microservice. We introduced the concept of micro element. We move micro element. I can explain you what are this kind of micro elements. Between membrane, between cloud, networking, IoTs, when you need some things, abstraction, you deploy there. You need it? Okay, switch on. You don't need it? Switch off. The osmotic process continues in other direction. Okay? You see, you can tune it. Do you need much more computation on the edge? Move the micro elements on the edge. Do you need less? Move micro elements. But everything should be smoothed down, transparent to the user. In federation, of course, with different aspects. Okay, this is an example of application. This is the osmotic stack trying to introduce with the Sharma and the others. Essentially, we are looking to have some kind of framework. I can explain each box what we are looking for. And this is essentially the idea. You have a different type of mail on the cloud, on IoT, and on the edge. What is great is to create some kind of barrier, a membrane. Everything inside that context should be smoothly managed. If something's happened, destroy the membrane. Avoid any interaction. You can have micro elements on the device. You see here, you can have micro elements on the cloud. On the edge, IoTs, and on the cloud. This is essentially the idea. We are looking for different layers on the cloud, on the edge, and IoT. Okay, this is essentially the architecture we are trying to create right now with the different engine, low-level engine and high-level engine. The idea is to have essentially some orchestration on the cloud, of course, some local behavior on the edge that allow you to have this osmotic behavior. Okay, you see, essentially, you have micro elements. Micro elements should change by itself. You don't need to tune them. It's automatic reconfiguration. You know it. Can we use Tosca? Why not? There is kind of a concept. By the Tosca, you can define an environment. It was a good year, the presentation of yesterday, of the environment of the node. Can we define it by the Tosca, this kind of osmotic environment? Why not? This is also one slide I put it there. Okay? Essentially, the idea of osmotic, what we are working right now, from the cloud to the edge, but even to the edge, from the edge to the cloud. This different modality. You have the cloud, you push micro elements, but even from the edge, you can push macro elements on the cloud and on the device. Okay? This is a new model we are working on with the novel architecture, and we are making some concrete stuff there. Okay? What are the challenges? This is the paper many times we are referencing. This is the brainstorming we have in Vienna to have some joint work with Sharam and the others when we started this concept of osmotic computing. Okay? Runtime microservice deployment. At that time it was a microservice, but now they are micro elements. We understood there are some things different. I can show you why. Configuration, networking, security, edge computing. You know already these elements. It's a part of your domain. You know that we need this kind of stuff in our idea. Some runtime microservice deployment. We know somebody can say, okay, but you are using this idea, except we're using containers, why not? Let's start from there. What we're trying to do is to have some abstraction that allow you to move virtual machines, containers, Node.js stuff smoothly. Who cares what they are? What is important to represent service? Okay? Creation of virtual IoT-based application, even in the IoT. Okay? We can have a microservice configuration when you have to start to meet some QoS constraints. And also, the idea is to use some genetic algorithms, network process. Repeat, I am totally sure some of you are already in the domain, okay? Because we are focusing the technology specifically for this characterization. We are looking at from the top, okay? Even the domain of networking. Can we try to deploy, as I asked yesterday, can we interact in container by the network, can manage them? The idea is to have some kind of osmotic computing management of this one. And then we are going to the edge computing for offloading, mobile offloading of services, of microservices. That's essentially the idea. And of course, to tailoring the microservices, adapt them on the edge. And of course, we have workload contention, monitoring, to understand what's going on, some QoS violation. But keep in mind, it's not only specifically for one domain. It's something to spread the overall from the IoT, the fog, and the cloud. Okay? Orchestration, some elasticity control, repeat concept we already know. And this is important to remark. We are not a microservice anymore, but we thought to have micro elements, microservice, and micro data. Because you have to bring with you not only the service itself, but how you have to configure it, how to change the behavior during the dynamic runtime. Okay? Essentially, I can show you the representation. There is some link between microservice and microdata. Of course, they are useful for you for managing the operating system of the service, to characterize the container, to characterize the node, to characterize the environment, okay? But everything in one domain. At the end of the day, will be only one MELS. This is the graphical representation of the different MELS. What is the challenge there? How you can connect all the MELS? How you can represent them? How you can move one MEL from one device? Example, you can have one MEL in air conditioning, okay? Or you can have one MEL on the projector. How you can move them? Respect to what you need. Example, if the projector has some metering of a temperature, you can use it for understanding what is the temperature there. Is it possible to move the MEL from the air conditioning or from the sensor we can have around in the projector? This is essentially the idea. What you are looking for is the functionality. Who cares what is the technology behind? Okay? These allow you to move MELs by itself. And the last final concept I'd like to introduce, I know there are so many, software-defined members. This is what we are working right now with the Sharam and the others. And so the idea essentially is looking for the security in this aspect. Okay? And looking for the members as a filter, as a gathering of gateways and proxy, and looking for the security. We scared a lot in security and IoT and stuff and internet. You know, in the past, there was the opportunity that hackers were able to switch on the camera baby in New York in the night, waking up the baby from the opposite of the world. You can go there, open the mic or open the speakers and talk with the baby. It's crazy if you think. You cannot imagine what is how people can scare about this. As you know also, there was LG, smart television, switched on by the company in Korea. They said to improve your service. Every time I hear I'm trying to improve the service, no, Sharon, I'm scared. I remember a friend of mine from Google, we are in Zurich, 2009. So Peter, I asked him, why I'm trying to make a search here in Zurich, everybody the same answer on I am in Messina. Oh, Massimo, we are improving the service for you. I understood they are tracking me. They said they are improving the service, but at the end of the day, they are tracking us. Okay? It needs not to happen. Okay. We have to put it in place technology, just to give an answer to Sharon many times we're talking this matter. We have to put in place technology that does not allow these people, this big brand, to operate as they. This is another solution in this domain. Software-defined membranes means you isolate everything in another domain, okay? You put everything there, okay? If something's happened, you have to destroy it. Destroy what? The cloud part, the big data part, the fog layer, the edge computation, the interaction with the device. If it's not secure anymore, you have to destroy it. The idea essentially is to have some kind of structure, I repeat, we're working on it, that allow you to gather all the facility you need there to secure them. If something's happened, you destroy it. This is essentially the idea. That means if you have some attacks on the baby, it's not useful anymore to have only switched off the camera, but you have to close the port. It's possible to buy the fog computing, not deliver any data on the cloud. You have to destroy everything because you are in trouble. You have not to allow the hacker to continue in X action anymore. This is what we are experiencing right now. Why it's possible to do it right now? Because we have abstractions. We have abstractions in the network, we have abstraction in the cloud, abstraction in IoT. Even the small camera, the baby camera, it's possible to deploy stuff there. Let's put an agent, osmotic agent, that allows you to have this kind of configuration. Repeat, osmotic, not from the scratch. We are using what is there, Docker, Kubernetes, Mesos. Repeat, it does not make sense to reinvent the wheel. Let's start with what we have. What is really interesting there, we are looking also what Kubernetes is doing. They are orchestrating very well containers, but repeat, our idea is to orchestrate them having in mind the process of osmotic computing. Even in JS, it's great to see there is some experience, even there, where you can consider meds. You have a serverless application, many things are on the client, because you have a small device where it's possible to have some JavaScript facilities. You can have also MongoDB in small device. Okay? Why don't gather them inside a concept of osmotic computing? Okay? Of course, you're using YAM, JSON, this kind of stuff. Tosca, simple profile. Let's start from there. Okay? And you see, these are the devices many times I mentioned it. This Raspberry is well known. What is happening also, there are small devices really cheap. It's a SP32 or SP8266. Okay, it's great because you have a double core, this kind of stuff. Repeat, we are making some experience with Raspberry, Docker, read-only mode, Kubernetes, this kind of stuff. The idea is to move in PXE, like network device is doing, a file system with the version with tags to know where you are. Okay, and this device, Python, MicroPython, MicroLua, constraint application API. Okay, this is a slide I just started. Can it be possible to use OpenTosca in this domain? It's a question mark. I think yes, because we are going in the same direction. To do what? Try to have some kind of osmotic environment to configure. Maybe this is an idea. I don't want to say the one idea is something that allows to make some harmonization of our overall system. Okay, and also to push this osmotic computing on the device. Okay, is essentially the idea. And you're using all the technology. We don't need to reinvent the wheel. This is really important, okay, to have this kind of concept. And we have some use case, we have some osmotic behavior, acquedotto of Recce, we have some experience there. Use case using the FFT is working. It's great because you can change how you can verify the pipeline of water moving, not only water but also the mass by all the device. Doing what? The fast Fourier transfer. This is what we process. And humans. Last year there was a great presentation. This is Aula Magna of University of Messina. I think Sharon knows it because a great presentation there last year for a conference. It was brilliant. I would like to share with you what was really brilliant from this person. He's the movie maker of Nuovo Cinema Paradiso. He took 1 hour to explain stuff, but what was amazing to me was half an hour he spoken about digital life. Okay? That pushed us to say, so we are entering a new era. He said that in the past, when we have to make a movie, we spend years. It was an example only to go on in a small village, you have to make some part of the movie, you have to knock people, can please remove the antenna? If you do it for 100 homes, you spend a lot of money, time, stuff, remove them, make the movies and replace them. Now you don't need it anymore. You take the computer and you remove by the computer. And for him it was amazing to say, okay, we're moving in new dimension. It was really great when he said, he's trying to figure out that the Kafka was trying to describe a beautiful night with a woman say, okay, I dreamed about you last night, you're so beautiful, you wake up in the morning, spend 20 minutes to say that. In the future, he said, you can have this situation, oh dear, I thought about you, I dreamed about you. In attachment, you can say my dream. If you see, it's really unbelievable where it's possible to go. This is the concept of digital life. This is why we are looking to be smarter, optimization, adaptation. What is important is a continuous dynamic. Virtual towards real stuff. Right now we are real, but we meet thanks to the virtual stuff. We are in the domain right now. Virtual meetings, virtual tasks, social behavior, real versus virtual, true versus fake, social versus isolation. This is what we have to really do. Smooth and not destructive anymore. We think also Osmotic can provide an answer there. Okay? User interface, smart osmotic cities, social, serverless, software-defined osmosis for people. You see here? Okay. Why I'm saying that? Because we are part of the game. We are trying to drain our ideas to others in osmotic procedures. Okay? Or from smart osmotic cities, where people is a challenge stuff, osmotic behave, and this is the idea, osmotic. Thank you.
Oh, thank you for the presentation.
Put it also on the face of the audience. Yes, Alfred.
Thanks, Massimo, for a great talk. You mentioned and defined the micro elements as new unifying abstractions
right.
We have to follow in osmotic computing. But I have to question if we have some transitions of existing structures to the new micro elements as unifying new structures. What would be the garbage filtered out by this osmotic filter? Is something which is not fitable in this new environment.
You are right. You define it garbage is great. If you define it garbage, you classify it in some way. Okay? That means it's not be part of the game. This is something that allows you to look to the future, understanding where you can harmonize. That means you can have some transient. You cannot put away in the garbage every technology, every stuff. It's something that allows you to have a common platform, to have the common behavior for what is looking for the future. But repeat, we already have some elements. We have a Tosca there, micro elements, microservices, containers. We can move in this direction. Already what we have, we can apply it, say, okay, we have some kind of osmotic behavior. And then let's give a look. In my idea, in my opinion, we can have a great benefit looking how you can manage this kind of elements. Repeat, look in your body. Your body has already this concept of garbage or moving stuff, because in my idea you need to have the basic setup, self-healing, can be done by osmotic behavior, where elements can move each other, can stay in one place, another one. In any domain, you can put a gateway to stay in the domain where you are. In any case, you have a filter, you can take what you require, you continue to be what you were before. This is essentially the idea.
It's more a vehicle for a soft transition.
Right.
Continuous transition.
Right.
Is the paper available?
Yes.
The paper?
Yes.
So, when I think about 30 years of computer science, and I think about something like agents running in a container of different sizes, micro-containers, meso-containers, and maybe cloud containers, and they interact whatever bugs they have at the moment, whatever. What's the real difference to osmotic computing?
Right. It's not only a matter of agent. I worked a lot on the agent in the past. There was this kind of aglets, agent platform, okay. What is different here, what to keep in mind, is that the concept itself. When I said I defined a software-defined membrane, is an environment, okay? Should behave by itself. The law should be regulated. Should be not the law of the edge, should be not the law of IoT, should be not the law of the cloud. Okay, should be some kind of regulated where this is the story. This is what they have to go to be part of the system. If you're moving away, you will be discarded, will be garbage. We have to guarantee QoS inside, security inside, viscosity. I'm thinking to introduce the concept of viscosity. What is this concept of viscosity? How you can flow. The data are becoming massive, so many data move out. They are not part of the game. The game should be in equilibrium. It's not a matter of exchanging data. No, 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 no. It's a matter of everything is staying inside, should be in equilibrium. Is something different, move out. Garbage on gateway. And something's happened, destroy it. Put a hole, some kind of iron, destroy it. It's not part of the system anymore. And you continue to stay, who cares? You are in equilibrium. I don't need to see how many data are there. No, you are basically on the rule of the same domain. This is totally new. It's totally new. It's not a matter of exchanging message. It's a matter of you exchange a message, agent, what do you want? But you have a part of the domain, and each of elements are part inside. Elements as a service, because a microservice, a data should obey this kind of behavior.
I have a question too.
Yes.
You said that you distinguish between microdata and microservice. What is the reason for that?
Yes. Essentially, let's say microdata are passive. Okay. Microdata allow you to have a configuration, to have to set up a dynamic exchange. Instead, the microservice essentially has to be active, and then microservices need microdata. But why I am saying for the same reason? Because you're in the domain, I can define the environment where elements can move. Okay. Only specific elements with the star that means microservice can be executed. In this case, you can apply some different behavior because they are active. They can be dangerous. Data are passive. You can exchange data. Yeah.
So how do you deal with migration of data? If you move, for example, some workload from one place to another, you also have to move the data.
You have to move the data.
Yeah.
You move the macro element.
You have to move a lot of data.
You
Right.
have shared data, right?
Yes. But all of them is a matter of the same membrane, what we discussed before. There are micro elements. Okay, you can move only the service, microservice, but you can move also microservice with microdata or only microdata. Okay? But what is important, you are obeying the structure of the membrane. What is inside can guarantee to you to have some kind of quality of service, the concept of viscosity. So because you are looking at some probe with everything inside this environment is working as you expect to have it. You can move data, of course. If you need to have a massive data, you can have the concept of set up the system, the channel to deliver data. Could be not micro, like micro elements, should be a service.
But does it really make sense to distinguish microdata and microservices? Because usually the microservices are
Microservice is active. Microdata is not. Microservice is active. You have to be careful to make a computation.
So microservice in your sense is completely stateless and without any data on it.
Right.
It's only connected to some microdata elements.
Right. You deploy it, start the system, configure it, and start to work. You can have serverless in this way. This is the idea. But repeat, we can improve it. There was some use case where we are applying it.
Do we have more questions? If not, and since we have time, Alfred has a short announcement. Might be good to include it now before the break. We are switching. Let's thank our presenters.
It's the good news here on the summer school together with Frank